Hello and welcome to our live stream. Today we're going to be doing a question paper from 2018. So I had a bit of technical problems. That's why I had to end the previous sessions and restart it. Yeah, something was not working right. But yeah, as I've already mentioned that we are going to be doing these questions every week. We're going to be doing different question papers, different questions every week from today until you guys write your exams. So every Tuesday. Yep. So without further ado, let us get started here. So we have this question paper and then question one. This is paper one, by the way, 2018 paper one. So question one says the 100th term of an arithmetic sequence is 512 and its common difference is 7. Determine the first term of the sequence. So we're required to find the first term of the sequence. We are given the 100th term. So this simply means that this is T100, which is equals to 512. And then the common difference, D, is 7. And then we're required to find A, which is the same as term number 1. So before we can find the first term, we need to know which, or decide rather, which formula we're going to use. The general formula for an arithmetic sequence is given as A plus n minus 1 times D. And then so we know that, okay, this is the common difference, this is the first term, this is the Tn, and then this is An, which is the term number. So now we can substitute what we know here. So we know T100, so where there's n, we're going to substitute 100. This is going to be A plus 100 minus 1 times D is given to us as 7. So I'm going to multiply by 7 there. And then we know that, okay, T100 is equal to 512. So therefore, we're going to substitute 512. This is going to be A plus 100 minus 1 is 99. Therefore, this is going to be 99 times 7. We're going to make A the subject of the formula because that's what we're looking for. So this is going to be 512 minus 99 times 7. Therefore, A is equals to, so this is going to be minus 181. That is the first term. So T1, which is equals to TA, is equals to A. So T1, which is equals to A, is going to be equals to minus 181. That is the first term of this question. Moving on to the second part of this question. It says the general term of a sequence is Tn is equals to it's 2a plus 3, and then we are required to show that the sequence is arithmetic. We know that for a sequence to be arithmetic, we need to have a common difference. The moment we don't have a common difference, therefore, we can't conclude that it is arithmetic. So without further ado, let us find out if this is arithmetic by first determining the common difference. But then obviously when you calculate the common difference, you need to know your first term, your second term, and your third term. You need to know at least 3 terms in order to do so. So then let us calculate the first 3 terms. So we're going to use this formula that is given to us, which is Tn is equals to 2a plus 3, and then term number 1, so where there's n rather, we're going to substitute 1. So this is going to be 2 times 1 plus 3, which gives us 5. And then term number 2 is going to be 2 times 2. So where there's n now, we're substituting 2. This is going to be 7. And then term number 3 is going to be 2 times 3 plus 3. And this is going to be 9. So remember what I said, right? We need to calculate the common difference. So D is given by T2 minus T1, which has to be the same as when you calculate it from T3 minus T2. So if we calculate and these are not the same, this cannot be an arithmetic sequence. So let us find out if really it is or not. So D is going to be T2 minus T1, which is T2 is 7 minus T1 is 5. This gives us 2. And then let us calculate it again, but then this time we're going to use T3 minus T2. This is going to be, T3 is 9 minus, and then T2 is 7. 9 minus 7 is 2. So the fact that these two are the same, they are equal, it simply means that this is an arithmetic sequence. So we can make this conclusion now. D is equals to 2, arithmetic, alright, now we're going to move to the next part of the question. So this one, it says determine in terms of n a simplified expression for Sn, the sum of the first n terms. So we're looking for Sn. First of all, because this we know that is arithmetic, we have two options actually to choose from. We can either use, because we know that we have two formulas that you can use for arithmetic series. So the first one that we have is the most obvious one, is the most commonly used one, is this one. It says 2a plus n minus 1 times d. And then the other one, it says Sn is equals to n over 2 a plus l, where l is the last term. So this is the last term. Basically, l is equals to a plus n minus 1 times d. That is the l that you see here, which is the last term. So, but then I prefer we use this one here. I prefer we use this one. So now we're going to substitute what we know. So Sn, we're going to leave it as Sn because they're looking for Sn. So when there's n in this formula, we're going to leave it as n. We're not going to substitute anything. So doing so, this is going to be Sn is equals to n over 2 times, we know our first term. Our first term from the previous question, T1, we know it, which is a. We know it to be 5. So T1 is equals to 5. And then D is given to us as, no, in fact, we've calculated D to be 2. It was not given to us, but then we calculated it. And therefore, we're going to substitute everything here. So A is 5 plus n minus 1 times 2. So Sn is going to be n over 2. It's going to be 10 plus 2n minus 2, which ultimately is the same as n over 2, 2n plus 8. Therefore, Sn is equals to, now we're going to multiply the n over 2 into the bracket, and when we do so, we're going to have n squared plus 4n. This is the answer. Moving right along. Now this one says, consider the given quadratic sequence, which is 4, 1, 14, and 25, and then it says determine a simplified expression for the nth term of the sequence. So this is quadratic, and we know that for quadratic sequence, the general formula is given as Tn is equals to an squared plus bn plus c. So our mission in this is to find these terms a, b, and c. If we find these terms, we're done solving the question. Without further ado, let us do so. Let us calculate these terms here. Let's try and find these terms. So the sequence is given to us as 4, 7, 14, and 25. So we're going to find the first, the difference between the first two terms. And then so we're going to say 7 minus 1, because it's T2 minus T1. So 7 minus 4 is going to be 3. Not 7 minus 1, but 7 minus 4. And then 14 minus 7, because this is term number 3 minus term number 2. So 14 minus 7 is 7. And then term number 4 minus term number 3 is 25 minus 14. Therefore, this is going to give us 11. And then we get the difference again. So doing so, 7 minus 3. So every time you subtract from the bigger term, the bigger term number, you subtract the smaller term number from the bigger term number. So term number 2, we're going to subtract term number 1 from it. This one gives us 4. And then 11 minus 7 also it gives us 4. So now that we're done with this one, we're going to find the formulas that you would use to calculate these term numbers. Term number 1, 2, 3. We're only going to focus on the first 3. You can do the fourth one, but the first 3 is sufficient to solve the question. So the formulas that we're going to use. So basically we're going to substitute for term number 1, right? We're going to substitute 1 here, and then where there's n, basically we're going to substitute 1. For term number 2, where there's n, we're going to substitute 2, and for term number 3, where there's n, we're going to substitute 3. Okay, doing so, this is going to look as follows. So this is going to be T1 is equals to, so it's going to be A. Instead of writing A, we're going to substitute 1 there. 1 squared plus B, 1 plus C. Therefore, T1 is equals to A plus B plus C. Because when you multiply this A with this 1, it remains as A. B with this 1, it remains as B. So we are going to do the same thing for term number 2 and term number 3. So meaning that I'm not going to write it here, but then for term number 2, basically, we're just going to substitute 2 here, 2 there. For term number 3, 3 here and 3 there. So this is going to look like this. Term number 2 is going to be, so when you substitute 2 here, or rather, when you substitute 2 here, this is going to be 4. So because it's going to be 2 to the power of 2, which is 4, times A is 4A. So this is going to be 4A plus 2 times B, because here we're going to put 2 where there's n. 2 times B is going to be 2B plus C. And then lastly, term number 3. So where there's n here, we're going to put a 3. When you substitute 3 here, it's going to be 3 to the power of 2, which is 9 times A is 9A. So you have 9A plus, you put 3 here, 3 times B is going to be 3B plus C. Okay, we're done with this step now. So because we got the difference between the first 2 terms, term number 2 and term number 1, so we're going to do the same thing here. So this is going to be term number 1 and term number 2. So the difference is going to be, so we subtract everything from this side to that side. So T2 minus T1, 4A minus A is going to give you 3A, plus 2B minus B is going to give you B, and then B minus B is just 0. So we leave it at that. And then you do the same thing for these 2 terms, term number 3 and term number 2. So 9A minus 4A is going to give you 5A, plus 3B minus 2B is going to give you B, and then C minus C is 0. So lastly, we're going to do the last part. So we're getting the difference between these 2 terms now. So basically what we're doing here is just that we don't have this section. So this one here, we don't have it, but then we have these other ones there. So we're going to say now 5A minus 3A, which is going to be 5A minus 3 is going to be 2A, and then B minus B is going to be 0. So let us name these steps. So I'm going to call this one step number 1, step number 2, and step number 3. So step number 3 is where we're starting. Rather, let me name them in ascending order. So this is 1, this is 2, and this is 3. This is 1, 2, and 3. So 1 goes with the terms here. So 1 goes with this term here. So we're going to equate 2A and 4. So we're going to solve for A. A is going to be 4 over 2, which is 2. So basically what I did is to divide both sides by 2. And then, let me write it properly here, because I don't want people to complain that it doesn't make sense. So we're dividing by 2, right? So we divide by 2, divide by 2. This will cancel that. A is equals to 2. So 4 over 2 is 2. It's going to give you 2. And then now we're going to take this part now, step number 2. So because this one here, we got it by getting the difference between term number 1 and 2. So it means we're going to equate it to this term here, number 3. Because the reason why I'm choosing this one is that we got this 3 by getting the difference between term number 2 and term number 1. So this one also term number 2 and term number 1. If you choose to use this one, which is the difference between term number 3 and term number 2, you need to come and get and equate it to this 7 here, which is the difference between term number 3 and 2. So going with this one here, we're going to have 3a plus b is equals to, and then so we're going to equate it to 7 here. Excuse me, we're going to equate it to 3. Therefore, and then we know what a is. A is, we got it to be 2, so we can substitute 2 there. So 3 times 2 plus b is equals to 3. And then now we can take the 3 times 2 to the right side. Therefore, this is going to be b is equals to 3 minus 3 by 2, which is minus 3. So we now know a, b. We're looking for c. So let us go ahead and find this one. So again, we're going to equate. So this one, step number 1, corresponds with step number 1 there. But then term number 1 is equals to a plus b plus c, which has to be equals to the term number 1 on our sequence there. So it means that a plus b plus c is going to be equals to 4. And then since we know a and b, we make c the subject of the formula, and then solve and substitute what we know. So this is going to be 4 minus a is 2 minus b is minus 3. Therefore, c is equals to 5. So now, remember what I said in the beginning of this question. I said we are looking for a, b, and c. Now that we have them, we are going to substitute back into this one there, and then we're done solving the question. So Tn is equals to, instead of putting a there, we're going to put 2n squared plus, instead of putting b, we're going to put in minus 3. So therefore, let me remove this plus. It's going to be plus 3n plus, and then the c now is going to be replaced with 5. And this makes the answer to this question here. Moving right along. So question 2, we are given this question here. So we're given this sigma notation. So this basically means that this is a summation. So I can easily equate this to Sn. So this is the same as Sn. We are summing. But as you can see here, the last term is x. Therefore, this n is replaced with x. But we'll get to that part. So let us do this part 1. It says determine the first 2 terms. So the first 2 terms, right? So normally with these sigma notation questions, normally when they give you something like this, so let me copy this here, n is equals to 1,108 times 2 over 3 to the power of n is equals to, so this part here, this part where it says 108 times 2 over 3 to the power of n, this is actually the general formula, which is Tn all the time. It's always like that. So this is basically, so we can rewrite it as follows, as Tn here, just like that. So from that we can make conclusions that, okay, Tn is equals to 108 times 2 over 3 to the power of n. So from this now we can find the first 2 terms. So term number 1 is going to be 108 times 2 over 3 to the power of 1. which gives us 72, and then term number 2 is going to be 108 times 2 over 3 to the power of 2, and then this is equals to 48. So these are the first two terms that they're looking for, 72 and 48. Moving right along. So we're going to this question here. So it reads as follows. It says if the sigma notation now with this general formula here is equals to 520 over 3, we are required to determine the value of x. So we do more or less the same thing, you know. So this is what we're going to do. So first of all, let us try and understand what we're given here. So we are basically, because remember, sigma, it simply means sum. So it means that the sum of all these terms from term number 1 to term number x gives you an answer that is equal to 520 over 3. So basically this is like this. Sx gives you 520 over 3. This is what it means. So because we don't know whether this is geometric or arithmetic, so but then one would make conclusions and assume that okay, this is geometric because it's exponential. That might be correct to some degree, you know, because remember there's different types of sequence and series. So it's not advisable to just make conclusion that okay, this is geometric. Yeah, you can do it sometimes and guess it correctly, but it's always advisable to just find out if this is geometric or arithmetic. So doing so, we need to know the first three terms. So term number 1, we've already calculated it to be 72. Then term number 2, we've calculated it to be 48. And then now we're looking for term number 3. 3 is going to be 108 times 2 over 3 to the power of 3, which is ultimately equals to 32. So we know the first three terms. Now we are going to calculate to determine the common ratio. So for this to be geometric, we need to say now the common ratio that we calculate between term 2 and term 1 has to be the same as the common ratio that we calculate between 33 and term 2. If it exists, it's equal to that. Therefore, this is geometric. So term 2 we know it to be 48, and then term 1 is 72. Because you know why am I making a difference here? Shucks. So I made a mistake here, right? You know, I'm solving the question using so I'm saying and I'm writing, but they don't go hand in hand. So this is what you would apply if we're trying to find if this is arithmetic. But because this is geometric, we're going to get the ratio between these two. Possibly here. So we need to find the ratio between these two. So it's going to term number 2 over T1. So erase this over T1. And that T2 is going to be T3 over T2. Okay, then we substitute now. Term number 2 is 48 over term number 1 is 72. And then this gives us 2 over 3, which is less than 1. So if we get the same value as this one here, therefore this is geometric. And if someone had guessed that okay, this is geometric, they would have gotten it right in this case. Term number 3 is 32 over term number 2 is 48. This becomes 2 over 3 as well, which is less than 1. Therefore, we can make a conclusion that okay, this is geometric. Okay. So now we can proceed now and find the value of x. So we're going to use this formula, this information here. So Sx is equal to 520 over 3, and then we're going to use this value of r than the first term. So let me write all that info here. So we know that Sx is equals to 520 over 3. And then we also know that A, which is term number 1, is 72. We know that R is equals to 2 over 3. And then, so we can substitute. But then also note that N is equals to X in this case. So the general formula for an arithmetic, for a geometric series is given as X is equals to A 1 minus R to the power of N over 1 minus R to the power of N. The reason why I'm using 1 minus R to the power of N instead of the other way around is because we know that R is between this ratio. So our common ratio is between this. It's between these two intervals. Therefore, we have to use this one. Excuse me. R is less than 1. Why am I saying is between? So R is less than 1. So because of this, we are using this formula here. So S of X is equals to, we know that, okay, the first term is 72, 1 minus, and then R to the power of N is the same as 2 over 3 to the power of X, because N is now X, over 1 minus R is going to be 2 over 3. You know, this formula, this N is not supposed to be there. Therefore, let me remove it. You know, before I was live, before I became live here on YouTube, I was actually live on Facebook doing the same thing. So I can feel it, my body is tired enough doing the same thing. And it took me an hour to finish that side. But anyway, let us proceed. So now we can easily equate it to 520 over 3. The reason why we do this is because we know that Sx is equal to 520 over 3. Therefore, we play around this, we manipulate it, and this is going to be, so this is what I'm going to do. I'm going to divide both sides by 72, and then I'm going to cross multiply this 1 minus 2 over 3 to the other side. So this is going to look like 1 minus 2 over 3 X is equals to 520 over 3 times 1 minus 2 over 3 all over 72. So I've basically divided both sides by 72, and then I've cross multiply this one to the other side. So now I'm going to take this one to the other side and take everything and bring it back this side. So here we're going to have 1 minus 520 and 1 minus 520 over 3 times, because this 1 minus 2 over 3 is the same as 1 over 3, so I'm going to multiply by 1 over 3 here, and then this is 72, which is equals to 2 over 3 x. This is going to be the same as 2 over 3 x is equals to, now this part here is just take it and put it in a calculator, and then when you do so, it's going to give you 16 over 81, which is the same as kk. So this is going to be 2 over 3 x is equals to, so 16 and 7 is 2 over 4. So I try to make sure that the values are the same. So this is 2 to the power of 4 over 81 is the same as 3 to the power of 4. So because of this is mathematics, get 6. So this can be, this limit is as 2 over 3 to the power 4 which is equal to 2 over 3 to the power 4. Therefore, we can make the conclusion now. Because the number is the same, x is going to be equal. So x is equal to 4. Interesting. So this is the question paper from 2018. So 2018 paper 1, and then question 1 and 2. So we're going to add the last here, and then you guys have question 1 we've done so far. You can leave the comments, and remember this is going to be weekly, but this time in the session because parents is introduced, so it's going to switch off. So I don't want to start that as question because it might not even finish the question. So it's better just end it for the question. But anyway, the question is this one here. And then the next one is supposed to be this one. So if it happens that maybe you want me to finish this question, then just leave a comment here. I will make sure that I create next week. I include this stuff that is missing on the next week's lesson. But anyway, thank you for watching, and have a lovely evening. Goodbye.